much, Jose, for organising the symposium, inviting me here, and for the kind introduction. So this is, as you see on this slide here, this is actually, I'm going to be mostly talking about some joint work here, which is, I started, but then because Jose and I have been collaborating for 2 or 3 years now, I guess, in the context of some OECD project on the future impact of AI on future of work and education. And so it seemed natural to involve Jose in a paper, which I'll mention in a moment. So, and I'll explain the title, what it means in a moment. But in case you're not, remember, if you're not familiar with LLM acronym before, remember that you'll need it. So I'm guessing that pretty much actually everybody in the room does know what a large language model is. But just in case, here's just a quick recap. These are generally generative pre-trained transformers, so they're pre-trained on very large corpuses of data, usually sort of scraping the whole of the internet and maybe more. And then they're trained up on this, and the idea is that they're then a model of the language that's found in this corpus, and then you can use that to do subsequent tasks, which is why these things are called foundation models, because they're foundation for building something else. But although large language models are often claimed to be foundation models, not all foundation models are language models necessarily. There might be ones built on other modalities. And usually for these downstream tasks, they have to be fine-tuned for that particular task. And as you can see, these things are huge now. GPT-4 has 1 trillion parameters, a huge step up from GPT-3. And as somebody who's been watching AI for many, many years, I'm really surprised how good these things are, or at least how pounding. I mean, it is, the level of fluency of these things is just amazing, at least to me, and I think to many other people. You could ask it to write in the style of the American Constitution about missing a pair of one of your socks. I mean, it's just amazing, and it sounds really fluent, often. So fluency is something they're good at, and often they produce really good answers, but sometimes they produce gibberish or stuff that looks correct, and there's been a lot of stuff in the press about so-called hallucinations, though some people don't like that word hallucination because it kind of applies a level of agency and understanding which maybe is, at least I would agree, is probably not really warranted. So, as I say, there's been a lot of, this is just, whole area has completely exploded. I was kind of aware of this a bit a few years ago, but now, as you see, I mean, I'm not going to go through all of this, this tree on the right, but it's just there to give you a flavor for, okay, you've heard of ChatGPT up here, and Bard up here, and GPT-4 here, but there's a lot of other ones here which you might not have heard of, and there's just a huge amount. There's a lot of closed source ones, GPT and Bard, but there's also some open source ones as well, and you can see that distinction made here with a different coloring scheme. The fact that closed source then makes them even harder to evaluate. If they were open source, open data, we knew what they were trained on, it would make it our job of evaluating these things a bit easier. But so, yeah, unless you've had your TV, radio, and social networks turned off over the last 6 months, you know what ChatGPT is. But I just wanted a brief recap. So there's a very active research area. Every week there seems to be a new paper or multiple new papers out in this area. It's really hard to keep, I try to do research now. I spend my whole time just reading about other people's research. People are working on new downstream tasks, new multimodal models starting to appear. And there's people are looking at different things apart from new downstream tasks, but also evaluating the capabilities and limitations. So my particular focus on this Turing project is going to be on Commonsense. I've got another colleague who's looking at theory of mind, and somebody else looking at somebody else. People are looking at the extent to which these things are biased, and given the training data is biased, and there's been a lot of talk about that in the press, it's not surprising that you get bias in the resulting large language models. And so I say my particular interest then is in spatial reasoning, with common sense reasoning more generally, but in particular spatial reasoning. And this is spatial representation of reasoning, something I've been interested in a long, long time. Pat Hayes, who you see pictured on the top right, was one of the early names in artificial intelligence, and he was my main PhD supervisor. And during that time, he started work on what he called naive physics, so our everyday common sense understanding of the everyday physical world. what happens if I were to tip this bottle upside down? Well, the floor would get wet, but if I tip this one upside down, then nothing would happen. And so he wrote several papers there, and I was a student at the time, but I got really interested in this, and so immediately after my PhD, I then started working on this, and I've really been working on aspects of spatial reasoning ever since, and you can see some of the areas here that I've been working on. And common sense reasoning, when I say CS, I mean common sense reasoning, has been mostly of interest in the symbolic AI community, but now recently to the deep learning community have taken a lot of interest in this as well now. So the question I'm interested in is, do these foundation models, such as these large language models, actually have common sense, or could they provide a foundation for common sense reasoning? So what kinds of spatial reasoning to test? Well, so something I've been particularly known for, and it's something I spent a lot of my career on, is qualitative spatial reasoning, which can maybe be broken down to a number of different sub-areas, things like Merrill topology. So Merriology is the theory of parts, and topology is when you take connections into account as well, directions, left, right, above, below, cardinal directions, shape, distances, relative distances, trajectories of things moving through space and time, and so forth. And of course, there's a lot of these kinds of spatial problems in existing common sense benchmarks, but maybe they're not testing these exhaustively. And so particularly these existing common sense benchmarks have a lot of potential flaws for the evaluation of large language models, and that's something that's being increasingly discussed at the moment. One thing that's been noted, I mean, this is not unique now to common sense, but more generally, the leakage from the benchmark into the training set of the large language model, which then means that it's like giving a student a copy of the exam paper before they sit the test. Even then, they're not explicitly memorizing these large languages, not explicitly memorizing, but clearly it is going to help them. There's often lax evaluation criteria. So, for example, with the so-called Winograd schema challenge, and I'll show you what a Winograd schema challenge is a little bit below, but basically it's where you get pairs of sentences and you have something like an word it somewhere in it, and you have to decide what the it refers to. There's two noun phrases, and you have to choose which one. And you really want to evaluate those things together, because if you just say, it refers to the same thing, the first noun phrase both times, you're going to guarantee to score 50%. But if you evaluated them independently, together, then that would then you score as a 0, because it really clearly hasn't understood the situation. You can get artifacts in the data set where maybe statistics can help disambiguate the pronoun resolution. And one example of that is, when the two noun phrases are a bus and a racing car, and there's about speed, and obviously, statistically, you know that racing cars are going to go faster than buses. And then there's a paper that, in fact, Ryan led on, that's recently published in Science, and they're using the way people use these common sense, these benchmarks, and particularly common sense benchmarks, is that they're just using aggregate statistics, so basically computing things like F1 scores and accuracy and so forth, can mask underperformance in particular more niche areas. And again, I'm not going to give that talk here, that would be a separate talk, but have a look at the paper. And the other problem is that often these benchmarks, they make it easier themselves to build the benchmarks and to evaluate them by having things like multiple choice questions. And indeed, that's also true of the Winograd schema challenge, because there's only two choices, the two noun phrases. But that means that you're already giving a helping hand to the system, because it's only got a small number of choices rather than it's going to find an arbitrary answer from scratch. So the thing that I've started working on jointly with Jose is this so-called dialectical evaluation, where we conduct, instead of having just one-off series of individual instances, we conduct an extended conversation with the system. And each question we ask may depend on the previous answer. And so the goal of this evaluation is not to produce aggregate performance values, not average accuracy or anything like that, but to find failures. So just one instance of failure is, even if it gets 99 things correct, that's still an interesting way of mapping the extent of the performance of the system. And so this gives us an opportunity to check for consistency and get more reassurance about anecdotal visions of the boundaries of the system. Of course, the disadvantage is it's hard to automate. You know, I spent doing this talk. I spent a lot of my time in front of ChatGPT and Bard, actually having conversations. It's a lot of fun, and sometimes I'm really surprised about how good it is, and other times I think really, particularly maybe when I ask the same question, just with changing some names. You'll see later. And I persuaded it to get the answer right for the first set of names, and I ask new names, exactly the same structure of the sentence, and then he gets it wrong. So this is kind of the summary slide from the archive version of the paper, which I joined with Jose. And obviously I'm not going to go through all of this, and you can't really read this, but I don't know whether actually, well, whether we want the stage lights off. But the thing I want you to look at this is the fact that we're evaluating 5 different large language models going across. We've got the first column here is ChatGPT 3.5 Turbo with the sort of web version. This is the playground version. This is ChatGPT 4 on the web. This is ChatGPT 4 on the playground version. And this is Google's Bard. And then in each case, we're evaluating 2 things: whether it gets the correct answer or not, and whether the explanation it gets for the correct answer is correct or not. Because sometimes it will produce the right answer, but give a fallacious explanation. So it's clear that it hasn't really understood and it's just got lucky, if you like. If you see a green tick, that means we qualitatively, subjectively, using our knowledge and experience as human beings, have judged it to be a good answer or a good explanation. A cross means we think it's definitely flawed. And we've got this sort of half means well, it's made a bit of a mistake, but it's not completely wrong. I don't want you to take that half as meaning 0.5. It's not a metric half. It's just, not completely right and not completely wrong. So you can see, and along the bottom here, there are some, and again, this is too small, but basically, in terms of just averaging this, and having just said that I don't want to use aggregate statistics to evaluate these things, I don't want to go and plug these numbers, but it's just interesting to briefly look at those. So ChatGPT 3.5 Turbo gets 19 right in both versions, whilst GPT 4 and Bard all get 30 right, ignoring any benefits from the halves. And the explanations, we have 14, 12, improvement now for ChatGPT 4, 22, and in the playground version 30, so it's better. But then Bard is much worse in its explanations. And it gets a little bit better, obviously, if you add in the halves. So I say, this is just to give you a qualitative feel that, if there was green ticks everywhere, I wouldn't have bothered writing the paper. There clearly are problems here in these large language models understanding the spatial representation, spatial reasoning. So I'm going to go through about 2 or 3 of these examples from the paper, just very briefly, just to give you a flavor of that. But mostly I'm going to focus on some new ones, which are not in the paper, and the kind of, I thought would be more fun to present rather than just repeating what's in the paper. So this is one of the ones from the paper, and this is the one I just alluded to earlier about changing names. So this is actually an example of one of those Winograd schema challenges I talked about earlier, because you can see there's 2 versions of this sentence. Tom threw his school bag down to Ray after he reached the top of the stairs. Tom threw his school bag down to Ray after he reached the bottom of the stairs. Who reached the bottom of the stairs? So the question in each case is, who does the who refer to? And in the first case, it correctly says Tom. In the second case, it incorrectly says Tom again. And this is again what I mean about evaluating both things together. So I then said, so this is the conversation I had with it, and I said, I sort of actually told it, think again. And it said, oh, it's always apologizing. I apologize for the confusion. In that case, if he refers to Ray, then Ray reached the bottom of the stairs. Well, it's a bit of a cop-out as an answer, but anyhow, so I thought I'd also test who has the school bag now. Does it understand about transfer possession? So yes, it does. I asked that, I think, in this case, and it got that right as well. But then I switched the names, so exactly the same sentence, but instead of Tom and Ray, we've got John and Frank, and it gets it wrong, even though it's got it right now with Tom and Ray. So, and this is actually I think about one of the only times I've seen this. So, of course, it is an extended conversation. It's all part of its context, and it hasn't been able to correctly disambiguate, keep track of which names. And clearly, if you're doing things like understanding a story, then you've got multiple characters in your story, and then keeping track of which character's doing what is just really important. So here's another example from the paper. Again, these are all ChatGPT 4 in the web version, unless I say explicitly otherwise. I have a child's shape sorter toy, which is slightly different to normal because actually they can all the shapes can fit through the circle, but the other ones can only fit through their own. So I say, they can all fit through the circle. Which of the shapes are supposed to go through the cutouts? And so it then says plus will go through the plus, circle will go through the circle, equilateral goes through equilateral, and so forth. But explicitly then, I mean, this is true, but it hasn't said that it will also go through the circle. And I might have given some benefit of the doubt, but then at the end it explicitly says, and will not fit in the other cutouts. So it's ruling out that possibility, even though I've said in the beginning, actually. So it's hardly any reasoning to do here. It actually has to just go back and read the original question again. So it clearly hasn't comprehended that properly. Interestingly, actually, this was done when we were writing this paper. I guess it was about late March we were doing this experiment, something like that. I actually tried it again this week. It gets it right. For all of the conversations I've had, and I think you've had as well with ChatGPT, we haven't given any feedback. You know, there's an option to give a thumbs up or thumbs down. I've not done that because I'm not trying to contaminate. I want to be able to go back later and try these things again and see if it's improved. Of course, there may be people watching in the background and noticing this is something, so it's not clear why it's got better. Again, if they made it open, we could see all the training data, including the human feedback, then we could see that. Well, there might be a huge amount of data, of course, but in principle, we could find out. And here's another one from the paper, and this is actually an example from a Commonsense benchmarks problem page curated by people from the symbolic AI community, Ernie Davis and Leo Morgenstern in particular. So formally characterize the structure of a metallic chain. What will happen if one picks up? This is actually a slight variation of what they said. I've adapted it, but it was inspired by their problem. What happens if you pick up one end of the chain and walk away? And I say a little bit what I mean by a chain because earlier versions of it misunderstood. So I gave it a bit of help there. And this thing goes on for long. I didn't want to put all of the response. It's a very long response with about 4 or 5 points. But here, as I pull the chain, it will result in the chain's length decreasing, which is clearly wrong. And if instead of being extended over the ground, it actually says it's going to end up in a pool of change forming on the ground or surface. So clearly completely misunderstanding what the task is about. Interestingly, though, the playground version of ChatGPT 4 gets it right. So given that the ChatGPT version on the web is based on the other one, it's a little bit surprising, but we have seen quite a bit of variation between the two. So this is a new conversation, which was inspired by, there's a spreadsheet on the web where people, if you're trying these things, you can then put in examples which go wrong. And so I looked at that, and I looked at examples of spatial reasoning, and actually there are only 2 examples of ones which are labeled spatial reasoning in that. It's one of my tasks to do when I get some time is to actually populate that, but I just haven't had time to do that yet. Anyhow, so there's a mathematical theorems about this, that how many points can you put on an n by n grid? And in general, the math says that it's 2n plus 1 is the maximum, where n is an n by grid. But it's not always as big as that. It might be smaller. I think it's more likely, the larger it is, the more likely it is to you're able to get more. So I ask, how can I choose the maximum number of points on a 3 by 3 grid such that no 3 in a line? Please show a diagram. I hadn't realized until I looked at this, you could even ask it to do a diagram. So it draws this cute little ASCII art diagram here. And it says, explains it. It says, as you can see, there are no 3 points x in a row, column, or diagonal. Hello. Clearly it's got it wrong. So I then had quite a long chat with ChatGPT 4 here, and I'm going to go through this fairly quickly, but I think I've actually got the wrong prompt here. My cut and paste didn't work because this is the same prompt as the one immediately before. So yeah, sorry, this is a wrong prompt. But basically, I pointed out that there was an error there, and it had thickness. So let me try again. Here's the correct way of choosing 5 points. There are only 4 points in your diagram. My apologies for the oversight. You have to correct. But this one's the same as the first one. Try again. This configuration, again, it's got it wrong. In fact, and then I carried on for a bit more, and I'm not showing you all of that here. I say, in fact, it's possible to place 6 points and on the grid and satisfy the constraints. I apologize for the confusion earlier, and now it actually gets it right first time. Congratulations. So I thought, is that the only solution? No, it's not the only solution. The arrangement could be rotated or reflected. Okay, that's good, to produce knowledge of the kinds of spatial things you can do, rotations and reflections, such that you, and it says there are 8 solutions. Well, actually, they're not 8, because 1, 6, and 7 are identical, 2, 4, 5, and 8 are identical. 3 is wrong because it's got 3 in a row. And 8 is actually a rotation, not a reflection, and can't be as actually what this one, this is actually symmetric about both diagonals, so clearly reflecting about either diagonal is not going to change its configuration. So, got some right, some wrong. I only want to count configurations which are not congruent. Moreover, one of your solutions is above has 3 in a row. I apologize. So now it tries to produce 2 new ones. First one is before, another one with a 3 in a row, and it's only got 5 points. I didn't actually point out it had 3 in a row. I just said it's only got 5 points. I apologize. And it gives me the same one again for the second attempt, for the second configuration. Again, it has a different one, but again, 3 in a row. And I now say, please annotate each diagram with a number of points. I was hoping it's going to do both columns and rows and columns, and maybe diagonals, but it only did the row. So now it's got that correctly for this. That's good, but I just wanted the other one as well. And it can't count. It's got 2 points, 1.2 points, that's only 5, but it says there's 6. Try summing the number of points I didn't point out. It had a row of 3 again, and its arithmetic is out yet again. I apologize for the confusion. And so finally, so then it says a single configuration with 6 points. But it seems to be misunderstanding what I meant by congruent, because it was allowing for rotations and reflection, as that was allowing. So I said I want to ones which can't be superimposed without rotation. So in that case, it's still having problems with 3 in a row, because it's now got 3 in a row horizontal. Read your first annotation above. The first annotation was 3 points in this row. So clearly a safe. The task is not 3 points in a row. It's got 3 points in a row. Let me just carry on to this one. So still wrong. Let me give you a hint. Take the first configuration and rotate it. And then now finally it gets it right. We've got the two configurations I was looking for. But it says they're non-congruent in the sense they cannot be superimposed by rotation or reflection. Well, they can be superimposed by rotation, but not by reflection. Okay, that was it. So that was, I partly went through that sort of long sequence there because I wanted to show you an example of an extended dialectical sort of interaction where we have this dialogue, and I'm trying to help it, but I'm also trying to test its limits of understanding. And it's clear that it was often not taking hints, or at least not remembering hints. And having once been pointed out, yes, you really got to check for 3 in a row, it was continually making that mistake. Now, in a way, maybe this is an unfair test of a large language model. I mean, diagrammatic reasoning is likely to be hard for something which is purely language, and maybe a multimodal version would do better. So, I don't want to be too harsh on the NLM here, but it's just kind of quite a nice example, I thought, of an extended interaction. I just thought I'd show you one example for BARD. ChatGPT-4 and GPT-4 is actually a bit better on this than the BARD, but I just thought I'd show you this because it also shows you the different style of answers that BARD has. So this is, one of the projects I've got, other projects I've got at the moment is an ESRC, which is a UK National Research Council and an American NSF project jointly with Stanford, where we're looking at various texts, Holocaust survivor testimonies, and these kind of travel writings from walks in the Lake District, which is a pretty area in the northwest of England. And I don't expect you to read or remember all of this, but basically this is just a description of what the things you might want to do if you're going from Penrith in the first instance towards then this large lake called Ullswater. Interestingly, the lake, although it's called the Lake District, none of the bodies of water in the Lake District are called lakes. They're all called things like water and meres and so forth. So, but anyhow, I'll be calling it a lake just for the purpose of simplicity. I've just highlighted these things are red because actually, they say this is taken from a text published in, I think, if I remember correctly, 1889 by this guy. Well, it's actually not, we don't know who the author is, but it's basically a travelogue. And I was actually sort of, because as you'll see in a moment, BARD actually brings in outside information, and it was giving me information which wasn't in my text. It was bringing in information it sort of had in its knowledge base or model from outside, and I wanted to start checking it. And then when I did that, I actually realized this was actually wrong. So the human writer actually got things wrong, and it actually, Hallenfell is actually on the east, Stuyberra Crag is on the west, and Birkfell is on the east. So I've done this actually twice, once with the incorrect version and once with the incorrect version. For ChatGPT, it doesn't really matter because it doesn't seem to generally doesn't need to make use of external knowledge in answering it. I said, here's a text, answer questions on the text. As you'll see, BARD actually brings in all kinds of stuff which is not in the text, which in a way is kind of fair, but I didn't say explicitly only answer questions based on the text. Just to give you a sort of diagrammatic thing of what's going on. This is Penrith just up here, and the journey that is being recommended is you go from Penrith to, this is a modern map, this is obviously, I've got access to the historical one, but the colour one's easier to see, the historical one's only black and white. So it goes from here to Emont Bridge, we cross the bridge at Emont Bridge, and then we take the first road on the right down here, following it along until we get to Pooley Bridge, which is both a town, actually both Emont Bridge and Pooley Bridge are both towns and bridges, which kind of doesn't really confuse us, but as you'll see, actually probably confuses the large language models a bit. Then what it's recommending is you then eventually go down to Patterdale via this, the western shore, but it recommends that first of all, you take a diversion of a few miles along the eastern shore and you get some nice views across the lake from the eastern shore. So that's just to visualize what's actually going on here. So its response, BARD's response to that was, sure, I'd be happy to do that, to answer your questions about the passage. And then it doesn't wait for me to ask it questions, it gives me questions and answers them for itself. You know, listen, read the exam paper. So anyhow, it asks some questions, which actually, and it does actually use some of my, it does actually here is using the text I gave it in its answers, and these all seem to be good. So now I can start giving it questions. Describe the route from Penrith to a place where a good view of Ullswater may be obtained. So sure, and now this is, you can see where it starts introducing external knowledge. Because I know where did I mention road numbers. In fact, actually, it's the A6 which you take, not the A66. A66 goes east-west. You'll be heading south, not north in any case. It's not 6 miles, it's about a couple of miles. It's at 1.6 miles. And the second thing is not when you get to Pooley Bridge, this is 4.7 miles. And you don't cross the bridge to take the viewpoint. It takes much longer than 10 minutes. There's all kinds of things wrong. So brought in external knowledge, which could be good if it was correct, but the external knowledge it's brought in actually is mostly wrong. So no, it didn't help. In which direction will I see views of the lake? So remember, this is when I'm going down the eastern shore of the lake, but it says you will see the entire length of the lake. Well, actually, that's kind of surprising. In fact, given the topography of it, because actually there's lots of mountains in the way. But that's why I put it in orange here, because it's kind of, you can't really tell either way without actually looking at the contour maps and doing some fairly detailed spatial analysis. In which cardinal direction are the views of the lake? So if you're facing the lake, the views will be to the south. Well, yeah, clearly they will be to the south. There will be some little bit of view to the north, but mostly I was expecting the answer. You know, if you're standing on the east shore, where's the view of the lake? You'd expect to say west, not south. I mean, although it's true, at least it should say, you know, south, east, and north, south, west, and north. The lake, it says the lake runs roughly northwest to southeast. When you remember that map I put up, actually it runs northeast to southwest. And it says the views will be on your right. Well, no. In which cardinal direction am I facing when you say the views will be on my right? It says, you know, if the views of the lake to you are facing east, but that's kind of, why would I be facing east when I'm on the east shore of the lake trying to see views of the lake? And then it's going to be more like right behind in any case. And in any case, given the northwest, the true northeast, north-southwest orientation, it was wrong. Ooh, what happened? Oh, I pressed the wrong button. How many bridges are mentioned which cross the Emont? So it says there's the only bridge over the Emont below Ullswater, but actually Emont Bridge goes over the Emont, as you might guess from the name. It says it's got the road name wrong again. Actually, if it was really using knowledge for the external database, actually the Pooley Bridge old structure, the grade 2 listed structure, got washed away in floods in 2015, and the more modern, which is well before the cutoff date, the more modern structure is actually not a listed structure anymore. So again, it's not actually fully understood the external knowledge base. And the Emont Bridge is not on the B6478, it's on the A6. Okay, which direction the second reach from the first reach? So it draws me this rather bizarre diagram with names of reaches which actually don't exist on the internet even. I've got no idea where it's got these reaches. The reaches don't have name. And Dungeon Gill is a place somewhere else in the Lake District. So all kinds of errors. And when it says if you look at the descriptions of the reaches here, actually, because it says the first reach is between Pooley Bridge and Glen Ridding, and the second one's Glen Ridding with Howtown. The Howtown is halfway between Pooley Bridge and Glen Ridding, so actually means the second reach, according to this description, is part of the first reach, rather than being separate. So I went on for longer as well, but that's enough for that. This is a kind of standard problem puzzle which people are often given. I thought I'd try it on this. There, we're back to ChatGPT-4 now. If I work 5 miles south, east, and then north, where am I? And it actually knows this is a standard problem. So this is obviously leakage from the training set. I think this is actually this is the most recent version. When I gave it previously, it got it wrong. But it's now got it right. And it's often, previously it was often expressed in terms of what color the polar bears. And because there are no bears on the South Pole, so it rules out the second possibility, which is, hadn't thought of the second answer, where if you're basically close to the South Pole, where the circumference of the latitude is 5 miles, and you start off 5 miles north of that, then that's also a possible solution. So it gets that right, but then I give it the sort of the flip version of it for the South Pole. If you go 5 miles north, 5 miles east, 5 miles south, and here there's one main solution, but it says explicitly now, unlike the previous case where you can be the South Pole, you can't be the North Pole, and so it says the only solution is South Pole, but clearly it's symmetric. So it's got it wrong again there. So it's surprising. Any human being, even if they haven't got the second answer, if I then told them the second answer, surely they get the second answer when if I ask them about the South Pole version. So yes, it then apologizes. So this is now sort of just reprising that thing about which directions are the views, but I'm now this is a new different conversation, not part of the Pooley Bridge conversation. This is ChatGPT-4, and I'm just asking it a series of questions about if I walk in different directions along different shores of the lake, where are the views of the lake. And so first of all, if I'm walking south along the western shore, which direction? So that clearly the views on that case should be on my left. It says now on the right. I also But it does get the lake in the direct direction. It says that the lake is to the east, which is correct if I'm on the western shore. If I turn around, it now, interestingly, it's, perhaps unsurprisingly, since it got it wrong here, it's now flipped right-hand side to left-hand side, which is wrong. The lake is on the left, again, which is wrong. But interesting, whereas it got east here correctly, clearly the cardinal direction of the views hasn't changed just because I'm facing a different direction. But now it's flipped this as well. If I walk south along the eastern shore, so this is now the eastern shore on the western shore, similar errors, though in this case, it doesn't make the second error. It gets it west correctly both times. If I ask at the southern and northern shores, I'm not going to show you those, but if I'm walking west along the northern shore and east along the southern shore and so forth, it gets those all right. So it's a particular problem about facing north and south. So some more questions now, new conversation about testing geographic reasoning. Lost track of time because I restarted it. 5 minutes, okay, right. If I walk, so the diagram is for your benefit. I didn't give the diagram to ChatGPT, but just so you can easily see what the answer is. So all the reasoning is correct until it gets to the final conclusion where it says the starting point is northeast, where clearly it should be southeast. But if I give a similar one, which is a little bit more complicated, it does all the computations and gets it right. So, win some, lose some here. It's not, it's interesting, it does, although I didn't explicitly ask it to compute the answer in this way, it's doing the sort of step-by-step reasoning, and these intermediate computations are all correct. Oh, yes. So here's a sort of standard geographical thing that geographers often talk about. Of all places, well, it's phrased slightly differently. I've changed the way it's phrased slightly here. Of all places in Nevada, east of all coastal cities in California. Anybody want to give me an answer for that? How well do you know your geography of the western US? The kind of first sight, you think, well, Nevada, if you know where Nevada is basically to the east of California. So the first naive answer would be that everywhere in Nevada is east of, particularly the coastal cities of California, which are right on the west coast. So even if there's a bit of overlap, you'd expect them. But actually, no. So it gets it correct, but then it then gets the reasoning is then wrong, because it then says the western border, it's got the two meridians here, but this first meridian is actually east of the second meridian, and therefore it's got it wrong. In fact, actually, the way it's normally phrased is Reno east or, so here's Reno up here, and here's San Diego down here. And you see, because of the way the coast of California really cuts in, actually, Reno is definitely west of Reno. And again, if it's looking up stuff on the web, it ought to be able to do that. It just looks up the lat long for each of them. And I have had conversations where it gets it right. So, okay, those are all the examples I want to run through. So let me, into my final minutes of the talk, let me just sort of go up a level of abstraction. I just wanted to point out this paper by Ernie Davis on Archive, which has appeared, I think, January this year, if I remember correctly, or maybe it was February. So, where he's talking about benchmarks for common sense reasoning and what's out there. And he starts off with this survey of what common sense knowledge is and is not. So it is really common. It's not something you need specialist knowledge for. It's largely sort of sensible rather than being sort of specialist. You'd have to be able to reason. It's not just about knowledge. That last example wasn't really about reasoning. It was really just about knowledge. So I wouldn't really claim that was common sense knowledge. Is independent of any particular modality or task, has broad scope, is distinct from common knowledge, which is things like London is a city in England, or that Spain is on the west, Valencia is on the east coast of Spain, perhaps. As concerned with generalities rather than individuals, is not book learning, and so forth. So he then produces a set of desiderata for benchmarks, which kind of should be easy for people if it's supposed to be common sense. The language should not be neutral, shouldn't incorporate undesirable biases or stereotypes, easy to evaluate with a clear-cut criteria for correctness. And he gives various examples then of common sense benchmarks which depart from these desiderata. So we're probably still looking out, on the lookout for the ideal, or a set of ideal benchmarks. Raises these, for general issues, should data sets be large or clean? Is it better to have a larger data set but perhaps some wrong labeling in it, or is it better to have a small, really clean data set? And with the original Winograd schema challenge data set was actually relatively small, only about 250 examples, but everything in there was correct and supposed to be Google proof. Should be beating the current AI systems be a goal? Should test sets be secret or published? And so he discusses these things, and he analyzes a whole set of existing benchmarks, and he gives pointers to that there in the paper, and he concludes with a set of recommendations that you really want high quality rather than large, focus on foundational common sense reasoning rather than common encyclopedia or expert knowledge, and we really want to extend existing benchmarks to have much greater structural richness and complexity. I think for the future, probably, I don't actually see foundation models, large language models, as being the one answer to AGI, to artificial intelligence, general intelligence. I've seen many, been around AI long enough, as Jose said, that I've seen many claimed solutions to AI in the past, Bayesian reasoning and expert systems and everything. And so it's not going to be a single thing which is going to, so we need to have multiple different kinds of techniques. And so I think this is one thing that I'm interested in working on in the future, and indeed other people are already working on it. We had one paper in cognitive systems, advancing cognitive systems conference earlier, late last year. I think, how do we use these models? I mean, I think there's perhaps a comparison with self-driving cars. If you look at the Tesla website, and it says explicitly, autopilot enables you to steer, accelerate, brake within your active supervision, assisting with the most burdensome parts of driving. So the Tesla website is not advocating the self-drive mode as completely autonomous. You should be in control. It's interesting to note that when you save these ChatGPT conversations into markup mode, it actually is labeled, rather than with this two little icons, it's then labeled human and assistant. So it's clearly seeing the system as being your assistant rather than being something more equal or autonomous. And so this was my proposed text then for a rewrite of the Tesla website for language models. So what are foundation models for? I think there's still an open question as what they really can be used for. But clearly they're, it's a major step for change in functionality in AI. It's amazing, the syntactic fluency. But you can't necessarily be relied on to be, not generate hallucinations or afactual, as I sometimes prefer to say. There's this paper by Bender et al. About surprisingly impressive fluent, but they're stochastic parrots. And so, they clearly can be a useful tool. People are using them. Microsoft are using ChatGPT in their customer service department to compose draft emails to reply to customer queries. So they're out there being used already. Many students are probably using it to do their homework, unfortunately. So we should be, as a human kind, we should be careful. So in conclusion, finally, just set of strengths and limitations. I think there are benefits for this, but of course, it's particularly this issue about it's very human intensive and hard to automate. So I've been thinking about how to at least partially automate this, perhaps using synthetic worlds, or I was talking to you yesterday with Jose about the possibility of using LLMs themselves in part of the automation, perhaps to help suggest questions. That's it. Future work, I'll just leave that up there and stop. Thank you.
For questions, have any question from the audience? Okay.
But yeah. What?
No, but it's for the recording.
So what are the kind of conclusions you can draw from this kind of evaluation, dialectic evaluation?
You mean what kind of conclusion would it be possible to draw in general, or from the particular evaluations that I've done so far?
Both.
Okay, so from the particular ones I've done so far, is that depending, even the same underlying engine like ChatGPT-4 or ChatGPT 3.5, you get different depending on the sort of the scaffolding around it, whether it's the playground version or the web version, you get different answers. So the same underlying inference engine can give you different kinds of answers, which might be right or wrong, or more extensive or shorter. To the playground version, the answers tend to be shorter than the ChatGPT versions. They can often get, it's the unreliability, the unpredictability, which has been. I'm not the first person to have said that. They can get things very right and produce very fluent and correct answers, and then the next question you ask them is that they get it wrong. And clearly, at the moment, they're still not able to take on board ongoing advice. They give it feedback not by the thumbs up, thumbs down button, but by saying, no, your previous answer was wrong, and it can't take that, even though it's obviously in its context, doesn't seem to be able to make use of that information in then answering subsequent questions. And I guess in terms of general, the question is this a good way of doing evaluation? And clearly, doing the other kinds of evaluation where you just have large benchmarks and you run lots of tests, I'm not saying we shouldn't be doing that, of course not. I mean, that's useful, but I don't think that's the only thing we should be doing, because those things can give a misleading impression and you don't get a good feeling. I mean, if according to the paper Ryan was first author on, and everybody actually published all of the instance data, and then you could actually start doing some more checking on the actual results and the results on the instance data, then that would make it a bit better, and that would be interesting for evaluation. But if they're just reporting aggregate results, and we as ordinary mere academics don't have the computational resources to run all the results that some other people do, it makes it much harder. Does that answer your question?
Yeah. Thank you very much for the presentation. At least to me, has been clearly interesting and inspiring. Thank you, Jose, for organizing this kind of events. It's a shame that there are not plenty of people, but the agendas of people sometimes are very complex. But it's really a shame that we don't take advantage of having you here and participate in your share of knowledge. So I wanted to wait for the end because my expertise in conceptual modeling and for information system engineering. So, I cannot enter in details. Of course, the ChatGPT wave, we are in the middle of this big disruptive appearance of these technologies, and everybody is just doing that. Let me just start by the end, because it's interesting to me, in our field, in information system engineering, when you create a software, a product, it's very hard to test it. So it's amazing to me that I did the product, and we all are testing it for free. And we are making a test of high quality as you do. So do you have some kind of reflection of that? Shouldn't you get some part of the benefit of ChatGPT is getting, because you are testing the product and you are indicating them how to improve it? Is it a right reflection?
Well, I mean, the argument I've heard people make, the argument, the reason OpenAI released ChatGPT 3 was they knew it was flawed, but they wanted to go and get the feedback. I mean, Jose was just saying this to me yesterday. It's a free way of getting thousands and millions of hours of feedback for free, much higher quality than you probably get from Amazon Turk, and which then enabled them to use 3.5 and then ChatGPT 4. So yes, I mean, they did have a red team, which most of those people got paid, but that was only a relatively small number of people. I mean, okay, if I'm, to a certain extent, I don't mind doing it for free, because these things are out there, they're going to be used, and therefore, if they're going to be out there, I prefer they're going to be good rather than flawed. and therefore anything I can do to help these things get better is probably better, because otherwise people may rely on them and, you know, then make errors which could be, you know, financially bad or, you know, in other ways bad. So, you know, in some sense that's yeah, a reasonable thing to be doing. But you're right, it is very different to something like a car, where, you know, a car manufacturer actually doesn't release a faulty, you know, version 1 prototype, sell it to the public, or even give it many copies away of the car for free and say, test it, and let me know how many times you're going to end up in hospital. You know, so it is, I mean, of course, the consequences of something going wrong with your not well-tested car are much potentially worse than here, where providing you not taking full, you know, not basing important life decisions on it. I mean, the barred version you use clearly says at the top left, experimental version or something like that, so that it's emphasizing.
Well, thank you. There are many things I would like to discuss with you, but let me just choose only one that is related to what we do normally. We have been talking in the past, for instance, about an automated, the programming machine. And it is a machine that you tell the machine what kind of program you want, and you have it. And only 10 years ago, this was a kind of crazy idea that now with this kind of technologies is very feasible, is approaching, is becoming a kind of real possibility. And also this is why many of us now we say that we are working now with Jose in an AI institute. I have never in my life did the AI before, but now we are saying that we do explainable AI because we try to, our conceptual modeling work is based on conceptualizing reality. So we defend always the idea that to have a good application, you need to understand the semantics, the description of the word in a common sense way. It is amazing to me that you use the common sense word. Well, it's a very important topic indeed. You just introduced. My question was, what do you really mean by common sense? Because for us, it's very hard to identify, ontologically speaking, to have a foundational definition of common sense. And without it, it is very hard to continue. But you also face this problem. So these last comments were, well, you know, we have a Spanish saying that says something like common sense is the less common of senses. In the sense that it's very hard to understand what is common sense. And also the point related to that is that, well, you talk about foundation model. When you see the word model, all my radars are on because we work with models. So this is my last part of the comments that I wanted to share with you. What is common sense really, ontologically speaking, is possible to define it precisely? And what do you mean also by a foundation model when you say that LLM are a kind of foundation model?
Okay, lots of comments. I don't think I remember all of them, but let me list the last two ones, which I do remember. So first of all, the easy one, the foundation model and LLM. So an LLM is a kind of foundation model, but not all foundation models are LLMs. So it's the kind of, you know, so for example, a multimodal system, which includes both language and vision, wouldn't strictly be just a language model, but it might be a foundation model. Okay, so then the definition of common sense. Well, I don't believe there's a hard, you know, it's not something that's a definable category. You know, there's some things which I could say are definite examples of common sense and other ones which are definitely not, but there's going to be this kind of blurry line separating the two, and you might say that's common sense, I might say it's not. You know, maybe there also might be things like age-dependent and culture-dependent. You know, different cultures might regard something as common sense or not. I mean, I would hope generally common sense, particularly spatial knowledge, would be culture independent, but you know, I can imagine it might not be completely culture independent. So, you know, I'm not going to pretend that there's a hard and fast, clear cut. You know, the world is separated into common sense knowledge or common sense reasoning and expert reasoning and knowledge. So, but there's clearly things on the back, and it's possible also that, particularly for the common sense part of it, so the knowledge part of it rather than the reasoning part of it, I suspect stuff kind of moves from the expert to the kind of the common part. So things that, I mean, 2 years ago, even 1 year ago, I remember the general public what a large language model, and people would have just looked at you blankly. And now, you know, it's on BBC News every other day. So at least in terms of what's common knowledge does change clearly over time. whilst things tends not to move, does it ever move in the other direction? I can't think of a good example of it moving in the other direction. It would seem counterintuitive to me.
Yeah. So my question is about the fact that you said different versions of GPT, for example, Playground and ChatGPT have different answers. So if this is the case, the answers of this system is unreliable in a way. And also it's hard to evaluate this system because one of them might be correct and the other one wrong. And it might be the case that if you ask the same question in a different time, then you get a different answer. So do you think, because you have did all these experiments, do you think that this is going to make it hard to evaluate these models? Because it might be a matter of chance that you get all the answers correct or wrong in different time that you ask these questions.
Yeah, I mean, of course, these things are probabilistic in stochastic in any case. So, you know, it produces an answer and then it chooses the most probable answer, but that can change. And then maybe, I'm not sure, maybe some of these models actually then maybe don't always choose the most probable answer. And certainly with BART, you can actually, there's a number of, it can say, you know, choose a different answer, explicitly says, or for ChatGPT 4, you can say regenerate it, it'll produce you a different answer. Yes, I mean, you can get different answers for different kinds of reasons. Sometimes they're just rephrasings. It's basically giving you the same answer, but it explains it in a different way or rephrases it in a different way. But sometimes it'll give you a completely different answer, which might be wrong or right. I mean, in a certain sense, you've seen that already, because sometimes I've asked a particular question, re-asked it a bit later on, and then it might get it wrong, or at least suddenly it will give me a difference. Or sometimes it will give it exactly the same answer, and sometimes it will just rephrase it. So, but of course, that's also true on humans. I mean, they're probably, you know, if I ask you the same question today and tomorrow, or if you ask me that question today and tomorrow, I'll probably give you a slightly different version of the answer. So, you know, I don't, that stochasticity I don't mind per se. It's the kind of the qualitative, you know, whether it's sort of qualitatively saying the right things and explaining things. And that explanation is kind of really critical, because that's, I mean, these large language models and neural models in general, that's the trouble, they're black boxes, and there's the whole thing about explainable AI. And we need to find good ways in order to build trust in these systems. We need to be able to have trust in them that they're going to reliably give us right answers. And one way of having trust in them is that they can explain their reasoning to us. And that's, you know, that's not easy, particularly to gain that trust, particularly when, and as you've seen examples here today, when it then gives you an answer which might be correct, but the explanation's wrong, or vice versa. It gives you the right answer, but actually the explanation's wrong. So, you know, and so particularly, I mean, sometimes it's interesting, and actually, I don't think I pointed that out. One of the examples, I think, in the 3 in a row example, because I was trying not to spend the whole of the time on that one example, but I thought it was interesting to go through that extended conversation. It actually gives the wrong answer to begin with, and then it starts explaining it. And then as it starts explaining it, it says, oh, hang on, I've got it wrong. And then, so it gives me a different answer at the end. And so I sort of, that's interesting, because it means that it is able to introspect on its own explanation, and then realize that what that then now contradicts what it said earlier. But has that answered your question?
Yeah. This example is very interesting. Is it included in your paper?
The only ones that were included in the paper were the things at the beginning about Tom and Ray throwing the bag. What was the other example? The shape sorter. And there was one, the third example, there was, I can't remember what the other example I did near the beginning of the paper, the beginning of the talk. The first 3 examples were in the paper. All the rest is stuff I've been doing this week. Yes. it's possible the polar example might be, no, I don't think it, no, it's not in there, I don't think so. No, I think those three are the only one that's in the paper. And the other, I was trying to, I was sort of interested, the paper is not about geospatial reasoning at all, it's just about other kinds of spatial reasoning. So I was sort of starting to try to write a paper about geospatial reasoning. And so I was then focusing on, that's why I did the Lake District one and the sort of the shores of the lake and the northwest, east, south, and so forth. There's a paper deadline on Monday. I don't think I'm going to make it, but that was kind of the task. There's a poster I can probably still put in. So I was focusing on that geospatial stuff, and I thought I'd make that the main focus of that. Apart from the 3 in a row one, which I just looked at because I was then actually searched for all the spatial reasoning examples in that database of failures, and I thought, oh, that's interesting, and I was surprised how bad it was at that. But maybe, as I say, maybe it's not being fair because it's diagrammatic reasoning and that's kind of hard. But the point is, it looks like it can do it. And this is the trouble with humans are, there's a word for it, when there's this anthropomorphism goes out, where something looks like it's human, you then tend to believe it is a human, you ascribe qualities to it that it doesn't actually have. And so because it looks like it's conversing to you in that, it's great fluent language, and therefore you think that it's, even going back all the days to Joseph Weizenbaum and Eliza many, many years ago, and his secretary was then playing with the system, and she thought she was really talking to a person because it had this fluency, and it seemed to give her sort of good answers. And so she was ascribing a much greater level of intelligence, even though it's just an incredibly simple rule-based system, which just looked for keywords in the questions and spouted stuff back. Or said, go on, tell me more, if it couldn't think of anything else to say.
Thank you.
So I was worried because, maybe Ryan was eager to speak, but we have decided that we are going to have a very short break. If you want to go to the toilet or something, just very short break, less than 5 minutes, and then we start with the next talk. But I wanted to ask a final question, and maybe this is something that we can continue discussion after Ryan stopped, because maybe it's a little bit philosophical. But I really like the problem of evaluating a language model, a proper language model, not a general foundation model that could be multimodal, on spatial reasoning, because this comes back to discussions about how far you can reach with a system that's not embodied.
Right.
And this comes back to Plato's cavern. So it's not something like the old discussions in AI. It's all discussions about philosophy, how far you can understand a world that you cannot interact with. So what do you think that there's some limits with these, or things are going to change significantly when we start just using images, for instance, with GPT-4, or maybe in the future you have a proper, and this is going to relate to the next talk where we're going to discuss a little more about embodied agents, perhaps? What do you think about this?
I think that clearly is going to help. When I drew the diagrams for some of those northwest, east, south things towards the end, and that's the way I actually worked it out. I actually checked the answer by drawing a diagram and then looked to see whether the starting point was, which direction it was, because that was the easiest way for me to do it. So that kind of diagrammatic reasoning, and there's a whole body, there's a whole conference series on diagrammatic reasoning. So it's kind of its own separate subfield of AI, which doesn't use, it's all symbolic, it doesn't use neural models at all. But if people are saying that these kind of neural models are going to produce AGI, which I don't believe, not without additional stuff, then it's going to have to do this kind of stuff as well. And again, the 3 in a row example is much easier if you sort of actually draw it out. And it's obviously seeing this, well, we see the diagram it's produced, but it's not actually, well, we don't know what it's doing, but it certainly looks like it's not really understanding the diagram it's drawn. I'm a firm, but some of the work I've done in my career has been on robotics. So, I'm a firm believer in it, sort of embodied AI, and having these systems grounded in. I've done work on grounding language to vision, for example, as well, and trying to learn the meaning of language there was an AIJ paper last year, or was it 2 years ago now? Last year, I think, on learning how to ground language from for revision sort of in a bottom-up fashion, but using a sort of correlation-based approach. And you can then get a much more robust grounding and definitions of your language by having it grounded in vision, rather than me trying to tell the system, rather than the system learning what left of or large or small or near or anything means by reading. It can actually see that by the combination of the language and scenes in which the red object is described as being near or to the left of the blue object. And it can get and you can inspect the model that we built, and you can actually see that it's understood the meaning of it properly. But no, I completely agree. And so I'm really I'm very frustrated I don't have access to multimodal GPT-4 yet.
Very much. So, yeah. We will be able to follow the discussion after Ryan's talk. Now, while we set up, maybe you want to go up, we'll start in 2-3 minutes.
Just as a final thing, I didn't put this in the talk, but you can get ChatGPT to play chess badly. And this appeared on Twitter, and there's this move. It suggests moving the rook from A8 to G8, and somebody suggests it should be called the atheist move because it doesn't acknowledge the existence of the bishop. Right, let me